Talk about x squared plus y squared equals 25. Thing one, without a calculator, without Desmos, as many numbers, as many pairs of numbers as possible that'll make that true. No calculator, no Desmos. I want you to think about this as opposed to just have technology spew out answers for you. Spend too much time having technology spew out our answers for us. No. We have technology so that when there's no need to think about it, they can spew out the answers for us. There should not be a substitute for thinking. Which is why so many people type in -4 squared in their calculator and then they write down -16. Because they're not thinking, they're just letting it substitute. As many numbers as possible. I definitely need more. There we go. One's a good start. I feel like +5 and 5 are the same thing. Or are those not pluses down to one? Oh, those are negative. Okay, because the erasing marks. Gotcha. Gotcha. That makes sense. Wow, good thing I asked him that question, huh? Lots more. Lots more. What?
Why?
You're telling me that 1 squared plus 2 squared is 25?
Oh,
I was right.
That's squared for some reason.
Wow, you're just focused on the fact that I didn't let you use technology, weren't you? It's all good. This is why we do something to warm up our brains. Really? 6 squared is 36, plus 1 squared is 1 is 37. No, it's okay. It's okay. You know, better that I bring it up now than it's awkward later.
Oh, that was supposed to be.
Oh, okay, okay. No worries. Sometimes 9s and 4s look the same. Depends on people's writings. Aha. That seems better, doesn't it? All right, let's see what we got. Give me 1. Let's just work our way around there. We'll start in the middle this time. Cohen, give me 1 pair of numbers.
0, -5.
0 and -5. Terrell, give me another pair of numbers.
0, 5.
0 and +5. Brooke, give me a pair of numbers.
-3, 4.
-3 and 4. Henry, give me another pair of numbers.
4 and 3.
4 and 3. Ryan, give me another pair of numbers.
3,
-3,
-4.
-4. Cohen, back to you.
-5, 0.
-5 and 0. Terrell, back to you.
5, 0.
5 and 0. Brooke, back to you.
-4, 3.
-4 and 3. Henry, back to you.
-3, -4.
-3, -4. That's starting to get confusing, isn't it? Ryan, back to you.
3, 4.
3 and 4. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 2 more. I'll take volunteers. 2 more. Come.
-4, -3.
-4, -3. Volunteer for the last one. Terrell.
Oh, wait. Sorry, I just saw the point that I was going to say.
I know. It's like, wait, what? This is hard to organize, isn't it? Let's see. We got negative.
-3.
4 and -3? Yep, that's it. 4 and -3. Nice. All right. It is now graph time. Boom. Draw a graph. Put all those points on it. Do it on graph paper. Ignore me because, I don't have that option. But I'm awesome, so it doesn't matter. I mean, look how good my graph is going to be. I'm just saying. When you get to the point where you're as awesome as me, you can do stuff on a graph paper. Just saying. Now you have a goal, a life goal. I feel like you're missing half the points. Dude. Where's graph paper? Graph paper back there if you're going to like grab pieces that have better graphs. Become a better person, all this stuff. Guys, here's the next question I want you to think about. Is this a continuous graph? Can I connect the dots or not? How do we know? How do we know? Anybody? What happens when I increase the value of x? What do I have to do in order to keep that equation in balance? If I make x slightly bigger, I've got to make y slightly smaller, which means that this is in fact going to be a continuous function. Now that's not a mathematical proof. That's just a logical proof, is that when I look at that, if I go from x equals 3 to x equals 3.1, clearly I could square 3.1, subtract from 25 and take the square root and get a value of y, which means that there's all these values in between. So we're going to go ahead and connect. Any theories on what this equation is? It would appear now, is it really a circle?
Probably not. I mean, I don't know.
Well, we could actually think, if we think about this a little bit differently. What's this going to be equal to? 25. Oh, absolutely not. Because that would be way out there. Right?
Oh.
that's gonna be equal to 5 no matter where I put my point along the edge, isn't it? Because that squared plus that squared is equal to this squared. And the definition of a circle is all points equidistant from some center. Well, every point on that shape is 5 units away from the center. So in fact, it is a circle, and we don't have to say appears to be anymore, because we can use Pythagorean theorem to prove that that's a circle, which is sort of nice. Sort of nice. Domain and range? Come on, give me one.
The domain is, x is greater than or equal to -5 and is less than or equal to 5.
Is there an easier way to write that?
Mm-hmm.
Brooke?
You could just do -5 is less than or equal to x less than or equal to, not -5, regular 5.
Regular 5, yeah. I like it. -5, regular 5. Yeah, we generally, when we've got an interval that's in between two numbers, we don't want to write it as two separate inequalities. It's not wrong. It's just awkward and weird and complicated, because then we have to really think about, well, what actually does that mean? Usually when we see two inequalities, what we're expecting is something like that. So you throw something unexpected at people, then they're more likely to misinterpret it. So yeah, it's right, but just generally not a good idea. Range?
Same thing.
Yeah,
but
it's the same
like
thing.
y.
Same thing, but with a Y, yeah. Ooh, how would we write that in set notation?
Brackets, -5, 5.
Yeah, brackets, not parentheses, because of the equals. Yeah, cool. Very, very cool. So here's what I want to happen next. Is I want to type this into my calculator. And of course, we all know that we could just type x squared plus y squared equals 25 into Desmos, and it would give us a step, but that's not what we're gonna do. What we're gonna do is we're gonna solve for y so as to be able to type it into our calculator. So right now, here's what I would like you to do. I would like you to start with x squared plus y squared equals 25. And I would like you to solve for y and then type what you get into your calculator and see if you get the same graph. Go. You gonna get the same graph?
I hope so.
Okay. Without even typing it into your calculator, are you gonna get the same graph? The problem here? What kind of graph is that equation gonna be? Yeah, but we didn't get linear when we did it by hand, so where was the mistake? Right? Next. Good first step. That's a good first step. Just out of curiosity, without even graphing it, what's that gonna be? Well, we knew that anyway, right? So, let's do space. There you can kind of say this. I would say that the square root of x squared plus y squared is definitely not x plus y. Because that's not how square roots work. You have to square root everything inside, like each individual thing. That makes sense. All right, guys, let's talk about the mistake that lots of people make, not just you. So don't feel bad. X squared plus y squared equals 25. Square root both sides. X plus y equals 5. Now, thing one. Do we agree that this thing was a circle and that this is a line? So right off the bat, what this tells us is that's not true. You can't square root the equation of a circle and get a line. When you square root the equation of a circle, what should you get the equation of? A circle, but written differently, agreed? When you are working with or manipulating an equation, all of your manipulations leave it the same shape, but written differently. And that's huge. That is a huge thing to remember. If you do something to an equation, both sides, same thing, and it goes from being one shape to another shape, you did something wrong. Can't happen. So let's look at another proof for those of you who are not 100% convinced. Do we agree that 3, 4 was a point on the line, that 3 squared plus 4 squared is equal to 25? All right, let's square root both sides. Ready? 3 plus 4 equals 5. Guys, again, pretty obvious when I put it that way, isn't it? Yeah. So why? What happened? Well, what happened is that order of operation says parentheses exponents. Hey, guess what? This is a parentheses. And this is technically an exponent, and we will talk about why a little bit later this year. Actually, you may have already seen that. That a power of 1/2 and a square root are the exact same thing. So really, another way to write square root of 3 squared plus 4 squared would be to say 3 squared plus 4 squared to the power of 1/2. We've got to calculate the thing inside before we can take the square root. So when you get rid of the numbers and you just make them x's and y's, same principle applies. We cool with that? Does that make sense to everybody? Okay. All right. So let's get rid of all this and let's see where we need to stop. What do I need to do first? First step. Getting y by itself. What is the first thing I'm going to do? Subtract x squared. I get y squared equals 25 minus x squared. Second step. Square root. I get the square root of 25 minus x squared. 5 minus x? Yes or no? No. I'm done. That is the equation of the circle in y equals form. And because I don't know x, because it's a variable, I stop right there. So, everybody put that in your calculator if you haven't yet. into your calculator, into Desmos, y equals square root of 25 minus x squared. What do I get? Which half?
So you need to replicate it.
Plus minus.
My mom would ask if you wanted a glass of milk, and if you said, just a half, please, she'd say top half or bottom half. Just reminded me of that. So how am I gonna get the other half of the circle?
You just make the whole square root negative.
Just like the sleeping parabola, isn't it? Calculator won't graph a non-function. Desmos won't graph a non-function if you type it in as a function. Y equals square root of 25 minus x squared is a function. It doesn't know you want the other half. You tell it, I want the other half by typing in also y equals negative square root of 25 minus x squared. Now, if you type in this, it'll draw you the full circle. The calculator, you can't type that in that way. All right. Questions? All right, next question. How do I take y equals square root of, plus or minus 25 minus x squared, and do a vertical shift? And how do I do a horizontal shift? And let's call it a vertical shift K and a horizontal shift H. Give you a second to think about that one. Where are you going to put H and K in that equation in order to get a horizontal shift and a vertical shift? If you're not sure, stick in a number, see what happens. See what happens to your graph. Henry, vertical shift?
Plus K.
Are we in agreement? Yeah. Yep. Same as every other function we've ever done. Terrell, horizontal shift? Where are you going to put that H?
Would it be x squared minus h?
You asking me or telling me?
That I'm telling you guys.
Hang on just a second. Obviously, they disagree with you, or they would have flung their hands in the air. But here's a question that I have for you. Is that where we put the H in every other case? Where did we put the H in x squared and x cubed and absolute x and square root of x and all of the different possibilities that we did? What was the one common?
Okay, it'd be x minus h squared. What in the do x?
Yes. Guys, remember what we talked about if we had y equals a function of x, the transformation was y equals a times the function of x minus h plus k. We always put a vertical shift outside. We always replace x with x minus h for a horizontal shift, and we always put the stretch factor out front. And we are not right now going to put a stretch factor out front because there's a little bit of a problem with stretch factor on this one. Yeah, if I put in a vertical stretch factor, a vertical stretch or compression, what happens to my circle?
It becomes an oval.
It's not a circle anymore because I stretched it in one direction. What we have to do is figure out how to stretch it in all directions at the same time. We'll talk about that after we get finished here. So let's do this. Let's go back to this equation. Y equals plus or minus the square root of 25 minus x minus 8 squared. I want to get it back to look like this. I want that 25 to be all by itself. What do you think the first step is to get that 25 all by itself? Oh, wait, okay. How am I going to get that 25 by itself? Terrell, first step.
Subtract k from both sides.
Y minus k equals plus or minus the square root of 25 minus x minus 8 squared. We good with that? My second step. Get the 25 by itself. Terrell knows. Anybody else? Go.
You square both sides of the
I'm
equation.
going to square both sides of the equation. Hey, what happens to the plus or minus when I square both sides?
Dead.
Goes away. Because positive squared, negative squared doesn't matter. I end up with a positive. So I've got y minus k squared equals 25 minus x minus 8 squared. Last step.
Add x. You add x minus h squared.
Add x minus 8 squared. You know what I loved about Terrell and Cohen is that they both put up their hands when they wanted to answer the question. But good answer. In a small class, it doesn't matter quite as much. In a large class, we have to worry about it a bit more. You notice something interesting? X minus h, y minus k. Once again, just like when we talked about the point slope form of the line, if we move the k over, thing Brooke was talking about yesterday is that, oh, look, the shifts go with the variable, and it's always variable minus shift, if you write it in this form. And this is a nice form to write this in. I would like you to type that equation into your Desmos. When it says, do you want to make sliders out of h and k, the correct answer is yes. Let's see what we can do with h and k. I want you to pay really close attention as you're dragging h and k around. What do you notice about the point h comma k? I feel like you got too many y equals in there. Yeah, because we don't need a y equals in this one, because this is, yeah, this is what's called an implicit equation, which is where x and y are sort of all just squished together instead of a y equals, which is an explicit equation. It says that y is equal to something. Brooke, you notice anything interesting about h comma k?
They do just what all the other graphs have done. H makes it go left and right, and K makes it go up and down.
So how about that specific point? Where would you find that on your transform graph, do you think?
Probably the origin.
Well,
Well,
almost. I understand what you're saying. The origin is 0, 0 on the graph. What happens when you move it by h and by k?
it just goes up and down. And left and right.
I mean, I think I'm not saying my question correctly. The origin right now here is the point 0, 0. So h comma k is the origin right here. When I move it, what do you find at that point?
Well, it's not the origin, it's in the middle of the circle.
There we go.
I just.
Oh, no.
worded it wrong.
My question was a little bit vague, and that's cool. But yeah, the origin is that one point on the graph. But when I move the circle, the center of the circle is h comma k. And it makes sense because the center starts at the origin. But if I move it 4 to the right and up 5, well, now the center's at 4, 5 because the whole thing moved together. Yeah, sweet. Okay, let's talk about stretch factor. We have already talked about the fact that if I just put in an a value, then I'm going to get an oval instead of a circle. So here's what I want you to do. Go back into Desmos and change that to a 36. See what changes. Everybody done that one? When you're done with that one, change it to a 49, see what changes. By the way, make h and k 0. It'll be easier to see these changes if it's centered. How about 16? How about 9? At some point, you may notice a pattern.
How does that work though? Like, it's on the end, or not really the end, it's like a whole nother part of me.
Right, you just delete the 25 and take 36 instead. See what it does to your circle, and then
I
delete.
know what it does, that's kind of the way to make it bigger and smaller, but I don't understand how. Because it's on the complete other side of the equation.
Yeah. So, what do we notice about all these numbers?
Perfect square numbers.
They're all perfect squares, but that's because I gave you perfect squares. But what does it tell you about the circle?
It's the diameter? No.
Like the minimum, it's like the negative number, and the minimum max, they are the square root.
Absolutely, absolutely. So the domain becomes the square root in each direction in the range. What else? You notice anything else? Henry? Nobody?
Sorry, what was the question? You're looking at Brooke, so I thought you were asking her to answer.
What's the radius of this circle?
The square root.
5,
5. What's the radius of that circle?
6.
The radius of that circle? The radius of that circle? The radius of that circle? As our general equation becomes x minus h squared plus y minus k squared equals the radius squared. H comma k is the center of the circle, and r is the radius. Why don't you go ahead and type in x minus h squared plus y minus k squared equals r squared, and it'll ask you to make a slider for r, as well as h and k, and then you can slide r back and forth and watch it go whoop, whoop, whoop. Now, if you have your computer sound effects set correctly, that's exactly what you'll hear. If not, well, then you can go home and work on it over the weekend.
That's life too.
Or you can make them yourself so you don't have to figure out how to get the computer to do it. Are we seeing it? That's the beauty of this, is the equation of a circle, which is a fairly complicated shape from the mathematical perspective. I mean, it's simple from a geometric perspective, but from a mathematical perspective, the equation just became insanely simple. If you see something with x squared plus something with y squared equals some number squared, it's a circle. And you know where the center is and you know what the radius is. So now, if I said x minus 2 squared plus y plus 1 squared equals 4, where's the center?
Would be
Where's the center? Could be
negative
any
2,
level.
1.
Can't be anywhere.
Oh,
Negative
right.
2, 1, really?
2, negative 1.
2, negative 1. Remember, it's minus h and minus k. So the center, 1, 2, negative 1. Boom, there's the center of my circle. What's the radius of my circle?
4.
No! Which means that my circle goes up to here, and it goes over to here, and it goes over to here, and it goes down to here. Hey, look at that.
That's not.
There's the circle, x minus 2 squared plus 1 squared equals 4.
That's not a circle.
I beg to differ with you.
Okay.
May not be drawn to scale. Or there may be a little bit of extra gravity over here for some reason.
It's because there's a big circle next to it.
Pulling, exactly, the
Oh,
big
there you
circle's
go.
pulling my little circle in that direction, distorting it. Hey, did you guys like the math question on the thing yesterday during homeroom? You leave your campsite, you walk south 3 miles, east 3 miles, north 3 miles.
That
I
one's
already
not
knew that.
going down.
Yeah, it is actually.
I knew the answer right away because
Yeah.
we did it in Mrs. Amy's class last year.
Spherical geometry. When you're standing at the North Pole and you go south, you can go anywhere around and you're still the same distance from the North Pole
They said 3 miles. I don't see how that's not.
3 miles.
because it's spherical geometry. Because you're looking at a triangle, but the triangle is overlaid onto a sphere. So you go around the three sides, and you end up back where you started. That make sense?
No.
So if you were to go outside right now, hey guys, if you were to go outside right now and walk 3 miles south, 3 miles east, and 3 miles north, would you end up right here? No, you wouldn't.
Well,
You'd end up 3
no.
miles over there.
Yeah, that's true. There's a few.
So you got 4 sides of a square, but when you start at the North Pole, because you're on a sphere, your south, east, north gets you back at the same spot. The only place on Earth that would happen, that and the South Pole.
So you could walk 3 miles and then just end up back where you were.
No, you walk 9 miles.
It's
And
a
if you
3.
walk 3.
No, you walk 3 miles south, 3 miles east, and then 3 miles north.
No.
So you'd have to walk 12 miles if you weren't at the North Pole. Because you'd have to then walk back west. What's that?
I said that I'm looking at the North Pole. That's one thing.
Yeah, your campsite's always closer, exactly. And then there's polar bears to eat you.
I mean, the South Pole.
And then there's penguins to peck you to death.
That would be great.
No, they're just gonna teach me the belly slide.
All right.
I just thought.
Hey guys, this is transformations of circle. Let's look at everything we've done so far. You don't have to write this down. You could just be paying attention. Guys, that's transformation of functions. What do I want you to know? I want you to be able to look at any one of these functions and say, I know what this looks like. I know that's a parabola. I know that's a cubic. I know that this is an absolute value function. I know that this is a hyperbola. I know that this is exponential growth or decay. I know that this is a sleeping parabola. I know that this is a circle. I want you to understand how those transformations work, and the fact that they're the same for any function makes that part super easy. But I really want you to know what A does, what H does, and what K does, and be able to pick those three things out of an equation. The whole point of this whole chapter is right there on the board. That's chapter 2. That's the whole thing. That was what our goal was. And when you get to calculus, assuming that you plan on taking calculus or that you plan on moving along, this is going to serve you in really good stead, because when you look at a graph or when you look at an equation, you will immediately be able to say, oh, hey, I know what that is. And so, for example, well, I won't give you examples right now, but being able to look at the equation and say, hey, look, that's got asymptotes, 2 of them. Hey, look, that's got a vertex. Hey, look, that has this inflection point right in the middle, and that's going to be pretty important in calculus. But being able to just glance at the equations or the graphs and saying, hey, I know about this one. I know what it looks like, and I know where all the interesting points are. I know where the locator points are, because the locator points become really, really important when we're dealing with calculus. And so that right there, if you can identify every single one of those functions and their transformations and their locator points, their basic shapes, you're going to be flying along and just going, oh yeah, that's that. Oh yeah, that's that. Oh yeah, that's that. Instead of every time you see a function having to type it into your calculator and then look. And you run into some problems if you don't know these. For example, y equals absolute x. And this is actually a fun one that we'll look at when we get to calculus. I hope you guys are all going to be in calculus because it's a lot of fun. Y equals the absolute value of x has a point right there. There is a function that looks exactly like that until you've zoomed in far enough. And when you zoom in far enough around that point, what you discover is that it looks like that. But you're zoomed in. You have to use like the zoom in feature on your calculator about 12 times. But when you get there, you discover that that function doesn't have a point. It actually curves around. It's just that the curve's so small that when you glance at your calculator, you go, oh, look, it's got a point there. And that can be a problem when you're dealing with calculus, because the fact that there's a point there means that we have to deal with that function completely differently right there than we do with this function. So when you see the absolute value function, you say to yourself, hey, I know there's a point there at the bottom. When you see something not the absolute value function, you know, hey, there's not a point there at the bottom. And it can save you a lot of time and a lot of heartache as you try to figure out what's going on down there versus just making assumptions. Oh, look, there's a point. Must be just like an absolute value function. Any questions?
Do you know the equation for the?
Off the top of my head, I don't. It's something like, it's the square root of x plus something squared minus something else. And it's sort of a weird function, but it's one of these things where if we are thinking about, you know, when we type that in and we look at this, we would say, well, hang on a second. This isn't an absolute value function. This is, in fact, some other weird combination of functions. And we should know in advance that, hey, look, this doesn't have a point there because it's not an absolute value function. What tends to happen is we look at it and we all go, oh, look, it's got a point. And then I say to my class, zoom in. Zoom in 10 times. And they all zoom in. And then they go, oh, wow, I have a point. Yeah, we
Or
do.
is it zoom
Where, what's
in?
that?
Like what is your scale of your graph by the time you're done zooming in?
I'm not 100% sure, but I want to say that this is probably 0.00001 to negative 0.00001.
Okay.
But that's speculation. I'm not really, I just know that we zoom and zoom and zoom, and all of a sudden we see, oh, look, a curve instead of a point.
Yeah.
Oh, look, this graph is going to work differently. Cool. What time is it? It's 11:49. We end at 12:40.
Okay.
So here's the deal, guys. This is everything I wanted to do with you. I'm going to put classwork 3. This is classwork 3, and I'm just going to put a grade. You don't have to turn anything in. I'm just going to put classwork number 3 into the computer. I really, really, really want Cohen to turn around and be faced this way when I'm talking and paying attention to what I'm saying, because I wouldn't say it unless I thought it was important. Next week, on Wednesday, we're going to do just a chapter 2 review, or I'm just going to bounce a bunch of problems off you. On Thursday, we're going to do the closure, and that's the end of the first chunk of 1 through 5. Unless I have my dates wrong, but I'm pretty sure I don't. I am going to assign you the chapter 2 test on Go Formative over the following weekend. Okay, so 1 through 5 ends Thursday. The test will be open. Take it before you come back Monday and start doing your 2, 4, 6 classes. And then I'll see you after spring break again. If you're missing assignments, please try to get them done. Don't wait till the end. Get them done, send them to me, I'll grade them. And keep that grade up. Right now, I've got a fair number of incompletes just in my classes in general because people haven't been keeping up with the assignment. So let's make sure that if you are one of them, you're getting that done now as opposed to waiting until June and then coming in and going, oh, this Saturday, I don't want to get an incomplete. What do I need to do? And then it's annoying for me as well as for you because then I have to be grading all the stuff that you're doing just to get points, not to learn anything. Whereas if you do them now, you're learning something. All right? So that's next week's schedule. Next week is basically chapter 2 review, chapter 2 test. And then when we come back from spring break, you guys know it's 4-5-5-4. Did we talk about that? We had 4 weeks of this, then we're going to have 5 weeks of 2-4-6. And the reason we're doing 5 weeks of 2-4-6 is that means we end at spring break instead of starting this class again and having it for 2 days and then going on spring break. So we do 4-5 and then we do 5-4. So when you come back, we'll have 5 weeks of this class. Hopefully, I don't know what we're going to get through. It's depressing to me that it is now almost the end of February and we're finishing up the second chapter in the book. Normally we get through 8.5 to 9 chapters in a year. But we will see. I gotta decide what to do during this second chunk. I may skip some stuff and skip ahead to things that I think are more useful for you guys moving on to pre-cal. And then I got to talk to Mr. Brannon and find out what, because he teaches pre-cal. And so, of course, part of what you guys will be doing next year is he'll be teaching you stuff that you need for calculus that maybe we didn't really get to. So it's going to be interesting. You guys are so lucky.
For honors, we expected 10 chapters, we thought like 2.
Yes, yes. What's that?
I was just making a joke about I can't wait to actually get a job from college. Maybe get into a college, hopefully.
Yeah. Well, the good news is that everybody's going through the same thing.
Yeah.
So the colleges get it. You know, we're teaching you as much as we can, and you're going to get to college, and your college professors are going to understand that you missed basically a year of learning stuff, and so you're going to be behind. I mean, calculus this year. One of the things I told my calculus class, the AP test gets you the first 2 quarters out of 3 of calculus, so you don't have to take the first 2 quarters. Usually, you can go if you do well on the test, you go straight into 3rd quarter calculus. I told my kids at the beginning of this year, I said, don't even plan on taking the AP test because we're not going to get to it. So what they're getting instead is they're getting as much calculus knowledge as I can teach them, which is going to be about half of what we normally would have learned. But that means that when they go to college next year and they'll roll into a calculus class, and a lot of it is just going to be like, oh my gosh, this makes so much sense. And it'll give them really, really good start to college calculus. So by the time they get to the part where we didn't get to do it, the stuff we normally would have done, they're going to be so good having doubled up on that first stuff. And that's not a bad strategy anyway. I did that. I went to a private school and I took calculus. We didn't have AP available to us back then, but I took my first year of calculus and I didn't get it. It made no sense to me at all. I was an average math student. I was a B math student. I took a year off. I joined the Navy. I came back from the Navy. I went back to college. I took calculus again, and I just rocked through. I mean, I had a 4.0 grade point average all the way through to my senior year. And the only reason I didn't have a 4.0 grade point average my senior year is I got mono. By the way, you get mono, Nothing's gonna happen. I would sleep for 12 hours. I would get up and go to class. I would go to work. So it was 3 hours of class, 3 hours of work. So that's 6 hours, maybe 7. I would go home and take a nap. I would wake up and do my homework and then go back to bed and sleep for 12 hours for a month.
Sounds fun.
Oh, it was awful. It was absolutely awful. So, but anyway, yeah. So I would say that for the next couple years, probably, you know, kids are graduating this year with my calculus class. Kids are in pre-calc right now, and then you guys probably going to just generally, we might be able to catch up some with you guys, but it may just end up being you take calculus, and then when you get to college, you take it again, and it just makes buckets of sense because you've seen it before. And then the year after that, with a bit of luck, everything will have been back to normal because the kids who are taking geometry right now will be in a normal Algebra 2 class next year. So, and then the kids who are taking algebra right now, what our plan is right now, I know this doesn't affect you guys, but you might be interested. We're going to spend about half of geometry just getting them caught up in algebra because there's a lot of geometry that you could just not teach.
Right.
And it's interesting and it's fun, but you don't really need it. You know, think about what you need from geometry. You know, you sort of need to know about triangles and sort of how the different relationships work. You need to know the sine, cosine, tangent stuff. Everything else is just interesting. Proofs, you don't really need to know how to do. I mean, you'll learn how to do proofs if you need it when you get to college. So anyway, there we go. See, I've rambled on for a good 10, 12 minutes. What I am now going to do for the next 43 minutes is I'm going to let you work on homework assignments. I'm going to let you dive back into Google Classroom, maybe get caught up on some stuff. You can ask me questions if you have questions. Since you're here, I'm here. If you have 100% of all your math assignments done and turned in already, and you have other stuff you need to work on, I'm okay with that. We'll ask you to be focused though. Let's take advantage of this time and let's really get some stuff done. And I guess nobody has 100% of their math stuff done because A, it looks like nobody has 100% done, and B, there's 2 more assignments sort of waiting for you for Monday, Tuesday. Also, guys, don't forget, you guys have been generally pretty good about it. Don't forget to go in and fill out that thing before noon every day when you're not here at school, because I do have to mark you absent. I don't know what being marked absent means, except that I think that if you're absent too many times, then the State Department of Education starts to come in and say, why are you absent so much? And they can actually harass you and your family and your parents and whoever else is at home because you're not technically going to school like you're legally obligated to. So make sure you turn those in. That way it's just no hassle for everybody. All right. I'm going to have to cut off the end of this because I rambled for so long and I don't want that on the live stream or on the recorded stream.